In this video, we're going to look at speed, distance, time, and real life graphs. So in question 10 here from 2022, Ali and John took part in a triathlon, a 5 kilometer kayak, 25 kilometer cycle, and 10k run. And the diagram below was drawn after both of them had finished the race. It shows how many minutes more than John or less than John. Just coming to the graph. More than John, it took Ali. Less than John, it took Ali. An unusual type of graph here. Don't panic when you see these. It's saying how many minutes here as well. And then the distance travelled in the triathlon. Between 0 and 40 for distance, obviously that's the distance. For example, point A, we take point A as an example, they're trying to help here. Shows that Ali took 1 minute more than John to travel the first 10 kilometers. 10 kilometers. And this is when they're level all along this line. So 1 minute more is here, 2 minutes more, 1 minute less, 2 minutes less. So the first question, did Ali finish the kayak session ahead of John, behind John, or in the same time as John? So let's just get rid of our markings. So kayak, well, she finished up here, so that's 2 minutes more than John, so she finished behind him. Ali had to stop briefly during the triathlon. Looks like it's at this point here. There's no distance covered. This time interval between two, it looks like a 1.5 minute time interval. 3 boxes, it's 1.5 minutes. John did not stop. State what distance Ali had travelled when he stopped and for how long he was stopped. So we're looking at this 3 minute time interval here. So just read this again. Ali had to stop briefly during the triathlon. John did not stop. State what distance Ali travelled when he stopped. Well, if he stopped, it's clearly at this point. If he stopped, he didn't travel any distance. I'm going to write 0 kilometers here. And for how long he was stopped, we can see it was 3 boxes, which is 1.5 minutes or 90 seconds. Or 1.5 minutes for this part. And this is the box that was given, so it says in minutes, so 1.5 minutes. Part C is what was happening John and Ali at the point marked B on the diagram. What was happening to them? What was happening John and Ali at the point marked B? Well, here's the point marked B. So if Ali was behind all along here, then behind all along here at this point, point B, Ali must overtake John to then be going quicker than him. So I'd say overtaking is what's going on here. That's saying that they all left at the same time at the beginning. And then the table shows the time it took John to complete each of the 3 sections, as well as his total time, 32, 38, 36. And use the diagram to fill in the 4 missing times for Ali. So we need to know how longer Ali took for the kayak. 2 minutes longer. So it's not 32, it's 34. The cycle, John took 38. And the cycle is between here and here. So if Ali was 2 minutes behind at the beginning of the cycle, and then 1 minute ahead at the end of the cycle, 2 and 1 is 3, was 3 minutes quicker. 35, so you can add these together. 32 and 38 is 70, and 34 and 35 is 69. So you can see Ali should be 1 minute ahead, which is correct. And then the run took 36 for John, and exactly the same for Ali, still a minute behind, so 36. So the total time for Ali will be 1 quicker, so 1:05. And John and Ali also ran a 400 meter race. John's average speed was 7.8 meters a second. It took Ali 2 seconds more than John. Work out Ali's speed for the 400 meter race. Okay, well, 7.8 meters per second by 400 meters is what you might think to do here, but it's 400 divided by 7.8. If it's running 7.8 meters in 1 second, it'll be 14 and 2 and so on. So we divide here to get the time. It's getting 51.282 seconds, and it took only 2 seconds longer, so 53.282 is equal to 400 divided by the speed, call it S. So the speed is going to be 400 divided by the 53.282, or distance over time, will be equal to speed. So 400 divided by 53.282 is 7.507. Correct to one decimal place, 7.5 meters per second, meters a second for part E. You should have seen one of these questions already, scientific notations with big numbers. Write it in the form a by 10 to the power of n. A has to be between 1 and 10, so it's 5.6 by 10 to the power of something. So let's just write 56,000,000. So the decimal is here. Now I've moved it back 3 places. Now I've moved it back another 3, so that's 6, so one more, so 10 to the power of 7. The diameter of human hair is roughly 0.0075. Write the diameter in the form b by 10 to the power of n, where b is between 1 and 10, so 0.0075 will have to be 7.5. So I'm moving the decimal in this direction, so it's by 10 to the power of not 3, you all know it's going to be minus 3, because we're going to the right. Lewis was driving 90 kilometers an hour when he sneezed. During the sneeze, his eyes were closed for half a second. How far did he travel in this half a second? Well, 90 kilometers an hour. We're looking for it in meters. So 90 kilometers an hour will be 90 kilometers, 1,000 meters, 90,000 meters per hour. So if I divide by 60, I'll get per minute in minutes. And if I divide by 60 again, I'll get what 1 second would be. 1 second. So 90,000 divided by 60 gives me 25 meters per second. So in a half a second would be 12.5 meters in half a second. Just be careful with your units in these questions. So here we have another real life graph. Poppy and Ella ran a 5k race. The simplified graph below shows the time it took Ella to run d kilometers during the race. Here we have 5k. Here we have the total time in minutes. Looks like just one above 25, 26 minutes for 5k. Distance is on the horizontal and it took 26 minutes. You can see here in the question. So the table below shows the total time it took Poppy and Ella to run each of the given distances in the race. Using the figures in the table, draw a graph in the diagram to show the time it took Poppy to run d kilometers during the race. So here we have Poppy, time in minutes, 5 for the first kilometer. So 1:5 is a point on the graph. 2:10, so 5 minutes again. As you can see, we're going to just give it a linear at 2 certain points. So this will go through here and here. It should be a straight line. And then 7 minutes, the difference between 10 and 17. So 17 up to 17 for the next kilometer. She's getting slower. So 3:17 would be here. Then we have another 7 and then a gap of 6. So 4:24 and 5:30. 4:24 and 5:30. So this is going to be a straight line as well. The second section, and maybe do it in a different color. And then the third section will be slightly quicker, 6 minutes. So you'd use a ruler in an exam, you'd have this perfect. And then we're asked to fill in the times for Ella as well. You can see she did the first kilometer in 4. The second kilometer up to 8. Total time, we're looking at the total time here. The third kilometer is at 14. The fourth kilometer is exactly on the line there at 20. And then we had 26. So what questions did they ask here? Show that Poppy's times do not make a quadratic sequence. Quadratic sequence, 5, 10, 17, 24, and 30. You know the rules for quadratic sequences. Second difference has to be the same. The first difference is 5, 7, 7, and 6. The second difference, 2, 0, minus 1. And you write second difference, not the same. Therefore, I'll just write it above here, therefore not. And repeat these words, quadratic sequence. It took Ella 26 minutes, as we've seen, to run 5k. Work out her average speed, just check the units. Kilometers an hour, now we have minutes here. So your distance, speed, time triangle, don't mess it up. Distance, speed, time. So S is average speed is equal to distance over time is equal to average speed. So 5 divided by 26, we need to multiply by 60 to change it from minutes to hours. So what does this give? 5 divided by 26 by 60 is going to give 11.538, 2 decimal places. 11.538, so 11.53 kilometers an hour. Careful with your units. In part E, we're asked to tick a correct box, so be really careful. What happened after 2 kilometers, which is marked A on the graph, and tick one box only. So let's just go back up to the graph and see what happened after 2 kilometers. So after 2 kilometers for Ella, what happened to her speed? Well, the first kilometer took 4. The second one is up to 8 minutes. That took 4. The third one is up to 14 minutes. So that took 6. So she slowed significantly at this point. 4 and 4 is, and 6 is 14. So just let's go back down. So you can see Ella's speed decreased. So it has to be this box. Take one box only. And 4 for the first, 4 for the second, and 6 for the third is the justification here in whatever way you want to write it. So, extending this question, Kieran also ran the 5k race and he drew a graph, and you can see it's not an exact straight line because it's going to be impossible to run exactly the same speed for 5 kilometers in a row or even 1 kilometer every meter, so it shouldn't be a straight line. But at point C here, something has happened. So after 2 minutes, Kieran has gone 10 kilometers. And after 2 minutes, after 2 kilometers, he's taken 10 minutes. And he's still at 2 kilometers after 15 minutes. So what does part C tell us? He stopped. We've seen this in another question in this video. He stopped for how many minutes? For 5 minutes. That's as much detail as they want. Brendan says Kieran's graph does not show total time as a function of distance. Give a reason why he's correct. So we've talked before about inputs and outputs. Inputs, outputs. So an input can only have one output. And if you input is an after 2, you input 2, you get 2 answers, 210 and 215. So you can add this too, so therefore it can't be a function of distance. Now we have a sequence question. Gertie writes down the following sequence, which repeats every 3, 3, 6, 4, 3, 6, 4, 3, 6, 4, 3, 6, 4. So there's 3, 6, 9, and up to the end of the 12th, the value of the 12th term, 4, nice and easy. The value of the 100th term, well, what can we say? Every third number is 4. 4, 4, 4. So we went all the way to 99. That's divisible by 3. That will be a 4. So the 100th one will be run after it. So back to the start again, back to 3. Describe how to find the value of the nth term in the sequence, where n is an element of natural numbers, without listing all the terms from first to nth. So how do we come up with the nth term of this sequence? So this question has been asked before, and it's based on a remainder. So if we look at the sequence 3, 6, 4, and we said the 100th one was 3. So 100 divided by, there's 3 terms in the sequence, would be 33 remainder 1. So what happens is the remainder is 1, it's going to be the first term in the sequence. Let's try that with 4 divided by 3, the remainder will be 1. You can see the fourth term will be 3 again. So this one, the remainder is 1. Similarly, 6, the remainder will be 2. So let's try, we know that 39, let's divide 41 divided by 3, would have a remainder of 2. That will be a 6. We also know that the fifth one here will be 6. 5 divided by 2 is 1 remainder 2. So you can check a few of them. And then what about 4? Well, the remainder would have to be 0. So it's this remainder based question that if you have knowledge of it is really straightforward. So you could maybe come up with your own question to describe any 3 terms in the sequence. Remainder 1, 2 and 0. Be careful that you can't get a remainder of 3 if you divide a number by 3. So a lot of words in this part. Gertie made her sequence 3, 6, 4, 3, 6, 4 by picking 3 as the first term and using this rule. If the term is odd, multiply by 2. 3 is odd, so the next term then will be 6. If the term is even, add 2. 6 plus 2 and half your answer. So divided by 2, 8 divided by 2 is where the 4 comes from. So this sequence follows the same rule. So we start with 8 is even. So we add 2 and divide by 2, which will give 5. Next term is 5, which is odd. So we just multiply by 2 to get 10. 10 is even. So we add 2, get 12, divide by 2 to get 6. 6 is even. So we say 6 plus 2 divided by 2. 6 plus 2 is 8, divided by 2 is 4. 4. And they've given you a little bit of help here. Then we come down to Ahmed. He takes 2 as his first term and uses the same rule. So 2 is even, it's the first term. So what do we do? 2 when it's even, just double check again, we add 2, divide by 2. 4 divided by 2 is 2. Second term is 2, so what's going to happen here? It's not going to change, is it? It's just going to keep on being 2. 2 is the first term. 2 all the way. 2 all the way. What's unusual is that the sequence just has the same numbers all the way through for Ahmed. In the next part, another sequence, the same rule. Second term is 86. Work out 2 different values. The first term could have been, okay, well 86, it could have been odd, so we could have had a number, let's call it x. This odd number multiplied by 2 is equal to 86. So it'd have to be 43. That's if it was odd. If it was even, the rule is add 2, divide by 2. So add 2, divide by 2. We go backwards and do multiply by 2, take away 2. What will we get? 86. We have to multiply by 2 going backwards. We do the opposite and then take away 2. So that's 172 minus 2 is 170. So 170. So let's just check that going forwards. 170 is the term, it's even. We add 2, divide by 2, which we do get 86. So they're just really testing your knowledge here. There's not many ways to practice these questions. A different sequence follows the same rule and starts with k, which is odd. So multiply by 2 to get the next one, 2k. Any number multiplied by 2 is even. There's an odd number by 2. 3 2s is 6, because any number multiplied by 2 can be divisible by 2. So 2k, what do we have to do to 2k? It's even. 2k, we have to add 2 and divide by 2. Now, I'm sure they'll allow you to write 2k plus 2 for this one, but 2k plus 2 divided by 2, divided by 2 is going to be k plus 1. And any number plus 1, if it's odd, is going to be even, isn't it? So we started with k, so we add 1 to an odd number. 3 plus 1 is 4, exactly. It's going to be, this one is going to be even. So then what we have to do is we have to say k plus 1. We add 2 when it's even and divide by 2. So it's going to be k plus 3 over 2 for the fourth term. k plus 3 over 2. So just try and keep to your rules and follow your rules. Don't worry about what k is or any unknowns within these questions.